Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. So fellas, now we are going to solve question 8 of this question paper. Okay. So if you have missed the previous question paper solution, don't worry, I'll put the link at the end of this tutorial. So stay tuned. So now, before solving this question, at first let us read the question. Okay. So phenol, this C6H5OH has a Ka value of 1.28 into 10 to the power minus 10 mole per dm cube. By the way, this is acid constant. Okay. So what is the pH of 0.1 mole per dm cube of solution of phenol? Okay. So before answering this question, let us know why phenol has acidic properties. Okay, so why phenol has acidic properties? Since phenol is an aromatic, since phenol is aromatic alcohol. Okay, so we call phenol as aromatic alcohol. So since phenol is an aromatic alcohol, so here this phenol also has some acidic properties due to some reason. So we gonna know some of the reason behind the acidic properties of phenol. Okay, which is also an aromatic alcohol. So normally alcohols doesn't show any acidic or basic properties. It is a neutral solution. Normal aliphatic alcohol, that is normal aliphatic alcohol has neutral solution. Okay, so normal aliphatic alcohol has neutral characteristics, but aromatic alcohol, particular phenol, has acidic properties. Okay, so we gonna learn those reason behind the acidic properties of phenol. Okay, in here. So here this is the structure of phenol. Here, as we can see, that this is pi bonds. Okay, continuous pi bonds over here. Just like benzene, phenol has the similar structure as benzene. Okay, so here phenol has continuous pi bonds. Okay, up and down. So here let's know some of the things. So phenol is basically an aromatic alcohol where OH group is directly attached to the benzene ring. So this part is the benzene ring and this is the hydroxyl group. Okay, well, so now let's know the reason behind this thing. The lone pair of electrons on the oxygen atoms gets incorporated into the ring. This increases the electron density inside the ring. Okay, so here since this oxygen has lone pairs of electrons, so here oxygen, the lone pairs of electrons of oxygen gets incorporated with the benzene ring. Okay, that's the reason. That's one of the reason. The lone pair of electrons on the oxygen atoms gets incorporated into the ring. This increases the electron density inside the ring. That is one reason. Pulling the lone pair of electrons from the oxygen atom cause the hydrogen atom to be more electropositive. Okay, so since these pairs of electrons of oxygen, since the electrons of oxygen gets incorporated with the benzene ring, this hydrogen becomes alone. Okay, this hydrogen becomes alone, totally alone. Okay, so this makes hydrogen atom to be more electropositive, more del plus. Okay, than it is in aliphatic alcohols. Okay, so normally this hydrogen over here is more del plus, this hydrogen atom on this phenol is more electropositive than it is in aliphatic alcohols. Okay, so that's the reason. So this means that the hydrogen atom is much more easily lost from phenol than that from aliphatic alcohols. Okay, so this makes this hydrogen atom to be separated from the phenol much more easier than from aliphatic alcohols. Okay, so this means that the hydrogen atom is much more easily lost from phenol than that from aliphatic alcohols. Thus phenol has stronger acidic properties than aliphatic alcohols. Okay, phenol is an acidic compound and thus it donates H plus ions then when dissolved in water. So that is why phenol shows acidic properties, since it denotes hydrogen ion or proton to water. Okay, so let's write the reason over here. Here the oxygen atoms electrons gets incorporated into the benzene ring. Okay, so this is one of the reason oxygen atoms electrons gets incorporated into the benzene ring. Okay, so this increases the electron density in the ring. So this increases the electron density. Okay, so this increases, therefore this increases the electron density inside the ring. Pulling the lone pairs of electrons from the oxygen atom, pulling the lone pairs of electrons from the oxygen atom cause the hydrogen atom to be more electropositive. So this makes H del plus in the phenol more electropositive. Okay, so since pulling the this benzene ring pulling the lone pair of electrons from the oxygen atom, this would cause the hydrogen atom to be more electropositive since it is alone right now. Okay, since it has no electron pair, since it is poor guy right now. Okay, this hydrogen atom has no money or electron. Okay, so this causes the hydrogen atom to be more electropositive than it is in aliphatic alcohols. Okay, so this means that the hydrogen atom is much more electropositive than that from normal aliphatic alcohols. So this makes H plus in the phenol much more electropositive than normal aliphatic alcohols. Okay, aliphatic, not phytic. Sorry fellas, I'm making mistake all the way. Aliphatic alcohols. Okay, now it's right. Okay, so this makes H plus H del plus, this makes H del plus in the phenol much more electropositive than normal aliphatic alcohols. Okay, so this brings so this makes phenol an acidic compound. So these things over here makes the phenol an acidic compound, and thus it donates H plus ions when dissolved in water. So it donates, not denotes, donates donates, okay, donates. It donates H plus ions when dissolved in water, okay. All right, so far so good, okay. So now let's see how phenol donates water by equation, okay. Where is space? I need more space. Insert space, okay. Now we have space. Now let's see how phenol then donates water, donates hydrogen ion to waters, okay. This is phenol, OH, okay, dissolved. This is liquid before adding water. After adding water, let's see what happens. H2O, liquid. By the way, this is a weak acid, so it will exist as equilibrium. So this reaction will exist as equilibrium since this is a weak acid, okay. So this is the condition of phenol after dissolving in water. So it turns into phenate ion, aqua, okay, and it does it produce oxonium ion, and oxonium ion is produced over here, okay. So here from acid base equilibria, okay, so from acid equilibria we know this equation. Let's write the equation for acid constant here, okay. So here on the right we have oxonium ion. We can write H plus instead of writing H3O plus. That's make the things much simpler. So here this is H plus ion, okay. The concentration of H plus ion multiplied by anion, which is this. Let's just represent this by A to make things much simpler, okay. So this is A. We are representing this as A, okay, A minus. Just like HA, we are considering this as HA. This is an acid, just like that, okay. So here we have anion of the acid, which is this. Now below we have the acid over here, which is phenol in this case. It does look confusing, right? Okay, let me label this in order to clear confusion, okay. So here in this case, this is phenate ion, okay. Here in this case this is phenol, and this is phenate. Which one is phenate? This is phenate, okay. This is phenate ion, good. So now let's know this is acid dissociation constant. This is acid dissociation constant, okay. Here let's okay. So here basically we don't write this thing. So here we are actually wants to find the pH of the solution So in order to find the pH of the solution, we need H plus ion. Okay, we just need H plus ion, we don't need this. Okay, we want to eliminate this. So in order to eliminate the phenate ion, the concentration of phenate ion, we do some assumption. Okay, so let's just discuss about the assumption. So first let us write the actual equation that we write. So the actual equation is this: H plus whole square. Okay, and this is HA. So now let's discuss the assumptions that we have made. So the first assumption, okay, the first assumption is the concentration of H plus is equivalent to the concentration of phenate ion. Okay, why? That's because very little H plus ion come from water. Okay, so very little H plus ion comes from water, so that doesn't makes any difference in concentration. Okay, so the concentration stays the same. So very little H plus ion comes from water. That's the reason behind this thing. So now let's discuss about the second assumption. Okay, so in here we have made two assumptions. So the first one we have discussed above, and now we are going to discuss the second assumption. So here the second assumption is concentration of H plus ion, initial concentration of H plus ion is equivalent to the concentration of H plus ion in equilibrium. Okay, here the initial concentration of H plus ion is equivalent to the concentration of H plus ion in equilibrium. Okay, because weak acids dissociate to small extent. Okay, so the change in concentration is negligible. Weak acids dissociate to a small extent. Since weak acids dissociate to small extent, this makes the change in concentration negligible. That's the reason. So that is why we will end up getting this equation. Okay, so now let's use this equation. So in here our objective is to understand this equation. So in here we are going to, since in here we are going to apply this equation over here, so that is why we have discussed this thing longer. Okay, now let's apply this equation that we have obtained over here. Okay, so fellas, I hope that you have understood so far. So if not, please let me know in the comment below. Okay, whether you have understood or not. So that is why we have discussed in details, just to understand this equation. So if we write this equation in the first place, then we won't able to understand. So that is why we have discussed the concept behind this equation first, then we are going to apply the concept and the equation as well. Okay, so now where we will go? Yeah, we will now go to the question. Pokemon, go to the question. Okay, so here is the question. Let me zoom this a little bit since it is looking small. Okay, so now we gonna straight write the equation. The equation was acid constant is equivalent to concentration of H plus whole square divided by the acid. Okay, in here the acid is phenol. Okay, in here the acid is phenol, so we gonna write the concentration of phenol, and we will use the Ka value that is given over here, and we will find the H plus ions concentration of H plus ion. Okay, let us just substitute the values. Okay, the value for Ka is 1.28 into 10 to the power minus 10. Okay, 1.28 into 10 to the power minus 10. Okay, then is equivalent to H plus whole square, then HA in this case is phenol. Okay, since phenol is showing acidic properties when dissolved in water, so here we're gonna consider phenol as acid. Okay, so here we just write the concentration of phenol, which is in this case is 0.1 mole per dm cube. Okay, if we make H plus as subject, okay, we're gonna get something like this. This is H plus, then root over, let's just do some of the arithmetic over here. Let's deal with some maths over here. Ten to the power minus 10. 10. Okay, so if we work this out, well, let us check whether this is correct or not. I am checking with this my solution. Okay, solution everywhere. Okay, let me get this correct. This is H plus. Okay, so here root over 0.1 into 10 0.1 root over 0.1 multiplied by 1.28 into 10 to the power minus 10. Yeah, fine, very good. So if we work this out, we're gonna get the pH value, which is 5.45. okay, so this is the answer. So now let's match this thing with the question, that the values that are given in the question. Let's just match this answer that we have obtained with the values that are given in the question. Okay, so this matches with this one, therefore the answer is B. Okay, so the answer is B. Okay, so fellas, I hope that you have understood the question as well as the solution. Okay, so that's the end of this solution. Okay, let's solve question number 9. Since question number 8 and question number 9 are similar in pattern, so now let's solve question number 9. So I hope that you have understood question number 8. Okay, we have discussed in details about the concept as well as the equation and calculation. So if you still have any confusion regarding the question 8, please let me know in the comment below. I am always happy to help you out. Okay, so now let's move on to question number 9. So we're gonna solve question number 9 in similar manner, just like question number 8. So just instead of writing Ka acid constant, we're gonna write base constant, which is Kb, which we will represent as Kb. Okay, so acid constant, the equation for acid constant and equation of base constant are similar. So instead of writing H plus, before we have written here H plus, now we're gonna write, here we have written H plus. Here, since this is base, since we are finding the base constant, here we're gonna write OH minus constant whole square. So here before it was acid, which was phenol, here we're gonna write the base. Okay, So here in this case the base is this one, C6H5 NH2. Okay. So we have constructed the equation for base constant for finding the base constant. Since we have constructed the equation for finding the base constant, now let's read the question and solve this question. Okay, so now we are solving question number 9. Okay, so so fellas, at first let us read the question. Phenylamine, oh nice rhythm, phenylamine, which has this formula, this molecular formula is a weak base. Okay, so this is the equation that is given over here. The equilibrium constant for this reaction is this. Okay, what is the concentration of hydroxide ions in mole per dm cube in this amount of solution of phenylamine? See here, since the concentration of the base, which is in this case is phenylamine, is given, we're gonna use this one, and we're gonna use the equilibrium constant, which in this case is Kb. Okay, Kb. So Kb is the equilibrium constant for this reaction, since this is a weak base. Okay, so now let's write right away the values. Okay, so here the value for Kb is 5 into 10 to the power minus 10, and we don't know about the hydroxide. So here they have asked about the concentration of hydroxide ions, so we don't know the value for hydroxide ions, so we gonna need to find the value of concentration of hydroxide ions. Okay, so we will leave it as it is. Here the concentration is 0.1 mole per dm cube, 0.1 mole per dm cube. Okay, if we work it out just like before, we're gonna find the concentration of hydroxide ion. Okay, so here, so in here let's make if we calculate this thing and make hydroxide as subject, we're gonna get something like this, 7.07 into 10 to the power minus 6. Okay, so this is the answer, mole per dm cube. So if we work it out, we're gonna get the concentration of hydroxide ion. So here let's match this thing with this answer. So here if we round this out, we're gonna get 7.0 this is gonna be 7.1 into 10 to the power minus 6 mole per dm cube, which matches with this answer, which is B. So here in here the answer for this question is B. Okay, so here let's talk about the assumption that we have made. Okay, since this phenylamine is a weak base, okay, so little hydroxide comes from dissociation of water. Okay, so little hydroxide comes from dissociation of water, and the second assumption is, okay, here is the first assumption. Where should I write? Okay, let's do this orally. So let's talk about the assumption that we have made. The first assumption is the concentration of phenylamine is equivalent to the hydroxide ion. Okay, the concentration of C6H5 NH3 plus is equivalent to the hydroxide ion. So this is the first assumption. Okay, So in here the concentration of this is equivalent to this, because once again little hydroxide comes from dissociation of water. This is the first assumption. Okay, just like before, similar to before. Okay, this is the first assumption. So first assumption is concentration of this ion is equivalent to the hydroxide ion. Why? That's because a little hydroxide comes from dissociation of water. Well, now let's talk about the second assumption. Okay, so the second assumption is concentration of hydroxide ion initially. The initial concentration of hydroxide ion is equivalent to the concentration of hydroxide ion in equilibrium. Okay, why? That's because weak base dissociates to small extent. Since phenylamine is a weak base, and weak base dissociate to small extent, so that's the assumption that we have got. So that's it, fellas. That's it for today. So fellas, I hope that you have understood the question as well as the solution. If not, don't hesitate to ask question in the comment below. Okay, so I'm always there to help you out. So fellas, that's the end of this solution. Okay, so I don't want to make it any further since the solution since this video solution is lengthy. It's quite lengthy, since we have discussed a lot about the concept regarding this topic, regarding this solution. So I want to end it right here. So fellas, let me know whether you have any confusion regarding this solution, which part I have